last week. We're still finishing material because we kind of backtracked a little bit, but this material is a repetition of something we did already last semester, but it's good to know how does it function now when you don't go and work on your work. So we'll talk about the ignition system. And we already talked about the nozzle distance, the spray angle, and the density, and atomizing. I would say atomizing is very important because if you don't get the right density of droplets, it might not ignite. So we talked about how we gap those nozzles from each other. Say usually it's an eighth of an inch, but every manufacturer have this distance to be calibrated based on the flow rate and the spray angle. So there is distance between the nozzle, between the electrodes. There is distance between the electrodes and the nozzle itself, too. And also there's distance from the electrodes to the turbulator plate, or the face plate in here, so it's not supposed to be touching. And if any of those get a little bit misaligned, you might have arcing to the casing. What is the casing made of?
Metal.
Metal. What does metal do?
Conduct.
Conduct. How much volts do we have in here?
Between 10 and 17,000.
Yeah. So that is very, very important to have them arc each other. And it's also very important to have what is the code now, which is called interrupted ignition. What does interrupted ignition mean?
It's not continuous.
It's not continuous. It will stay until we prove the flame, then it will cut out. All models that have something called intermittent ignition, which means constant. The whole time the ignition is constant, which was very, very wasteful. So those electrodes are held by a ceramic holder and a spacer that keep it in place. So make sure when you put it in there, it's in place. The center is not touching anything. Be very careful touching the casing while the electrodes are on. Again, we will have sometimes an ignition transformer from the outside connected through wires, or sometimes we have the big transformer that actually will hit the bus bars. Those called are the bus bars or ignition cables. In many cases, especially with the Beckett's models, the connections are not really well made. So as you close everything, those will disconnect and you don't have ignition. So it's good to verify if you have ignition and you have spark at the end before you start burning. So we have the first one, which is the interrupted ignition. The ignition sparks for a very short time. Once the CAD cell sees the flame, it will cut off the ignition. It means that we have proven the flame. No need for continuous ignition. That's called the interrupted, even though it doesn't sound like it's constant, but it means it's constant. Actually, it's interrupted like it will go away. The intermittent, even though it means it's not continuous, it is continuous. So be aware of those two words because it will come in the oil burner exam. Some old models have still constant ignition, but it's not the code. So for intermittent, the spark remains as long as the burner is running, and it's also called constant ignition. So interrupted, it will stop. Intermittent will continue. We don't want the intermittent one because it's just wasteful. Once the fire is going, it should go. Make sense? Clear? Okay. So the transformer, so we said also at some point, electronic igniters, try to distinguish between electronic igniters and transformers. Electronic igniters are very lightweight, inexpensive, and they use an electronic board to intensify the current and can produce up to 17,000 volts. And they either work or they don't. But based on replacing them so many times, people went back again to using transformers. So you will see transformers, the heavy transformers in the installations. And a transformer works using induction based on the number of windings. So if we have the primary is usually the current coming in. So your primary is what you put into the transformer, which in this case is 118, 120 volts. and the secondary is what you get out of it. So, for us to get 10,000 volts from here, we will need 60,000, what is it, yeah, 60,000 turns to get that amount of voltage. So you're putting in 120 volts and you're getting 10,000. So you have to multiply and add more turns. So we are inducing current into this iron core. So remember when we did the measurement for amperage, and we said if the amperage is too small and we're using clip-on meter, what do?
You coil it.
You coil it,
And then divide it by how many
then
times.
divide it. So if you coil it 60,000 times, this is the amount of voltage you're going to make. The more turns you make, the more induction you'll absorb and more voltage come out of the transformer. It's using electromagnetism and induction through an iron core. 120 volts to 10,000 volts.
That's what you're transforming it to.
Yeah,
Okay.
so it's stepping up. And the same concept actually also work with transmission of voltage. The power plant generates 10,000 of volts. It goes to a substation in the neighborhood, and that's around 4,000 volts. Then it goes to another substation, and eventually it goes to your control panel at home at how many volts, Lance? Now coming to your house.
Oh, coming into your house,
Yeah.
120,000 volts.
No. How many volts come into your house?
240.
240. Two hot legs of 120 each.
Yeah.
So you don't want a lot of high voltage into your house, you want something reasonable. Solid state is a track transformer to a 314,000 and 20,000. So it's really higher, but again, the reliability is questionable. Which is better, it depends. Again, we cannot always determine. Electric's life is significantly reduced. The comparison here is between constant and intermittent. Sorry, interrupted and intermittent, interrupted and constant. That's what we are comparing now. So, electric's life is significantly reduced when you keep the current going, right? Because you're always going to have 10,000 going through your electrodes. After a while, they will wear out. For example, every 30,000 miles in your car, you will have to change the spark plugs, depending on how they're made and what is the life expectancy on it. But if you look at it, if you compare an old spark plug and a new spark plug, you can see the tip is kind of worn out, and the metal itself is kind of burnt out, it's changing color, so it's not conducting as it's supposed to. Igniter, the ignition transformer life is significantly reduced because you're keeping it on all the time. So you have to, it's not good to have it on all the time. And also, if it's on, it's going to consume more power, right? So power consumption of a transformer is around 150 watts. That's a lot of money. If you keep that on for 12 hours a day, that will cost you a lot of money. Operation and noise is reduced dramatically if you have interrupted ignition. You can hear the buzzing. If you have a gas furnace, probably once you turn it on, you'll hear the ignition coming on and off until it comes out and then the light is shut off. So the buzzing is really loud, so it will produce the noise. Intermittent ignition may hide combustion problems that can cause soot that plugs the boiler and oil running saturation. So if you have constant ignition, whether you're running lean or rich or too much oil coming in, it's always going to burn because you have a source of ignition the entire time. I'm gonna write the equation of combustion again. So we have fuel. Spark. Equals heat, CO2, water. if you keep this on the whole time, you're gonna burn whatever comes in. So this, make sure that this could be up, this could be down, but you're still going to burn whatever happens, and you'll have another byproduct. Which is smoke, sulfur oxide, nitrogen oxide, and CO. You don't want these byproducts, and by having constant emission, you might have those byproducts. So if your car is, again, I always go back to the car example. If your car is burning oil or having complete combustion, you will always have issues with, the car will still run because you always, at each cycle, you will have a spark. And it will always burn, but again, you'll have some smoke coming in, but it will still run. Same thing will go here, it will still run, but it will be in complete combustion. Nitrogen oxide emission are higher in constant emission, and again, Massachusetts is a low NOx state. They don't want you to have nitrogen oxide. The X here stands for any number of oxygen. It could be NO2, NO3, NO1. So any kind of nitrogen oxide is not preferable, or also sulfur oxide. Question? So which is better?
It's definitely incomplete, yeah.
Yeah. Which is better?
Interrupted.
Interrupted is better. Once you prove the flame, just stop. Transformers, again, this is what it looks like. We do not fix transformers, we do not open it. It is completely sealed. The wires here are insulated with tar and completely sealed. We learned 3 ways to test that. Actually, more than 3 ways you can test it. Can somebody remind me, how do we test a transformer?
The actual device that tests
Actual voltage measurement?
continuity.
Yeah.
Ohms.
Continuity, ohm comparison between each lead. Also, you can run it. I look for the spark, but that's not very.
The color.
The color, what is the color?
Supposed to be
Is
orange.
it blue? It's orange this week. Also, one of the good ways to test the transformer is to turn it on and measure the amperage. And it should not drop more than 10% within 5 minutes. So again, as it heats up, let's say it was cold, then it heats up. What happens to the resistance when things are hot? Increase or decrease, Anthony? What happens to the resistance when the wire here is hot? Goes up.
Yeah.
So it goes up, meaning it's not, the current's not going to be the same, meaning this will be a little bit weaker. So if we have a weak spark, it's not going to ignite as fast. It will take it at least the 3 trials, then it will go in safety. So we have to try for ignition 3 times. If we do not do that, it will go in safety. So to keep going in safety, you have to go and check those little things. And it could be a little bit challenging to know why is it going in safety. So you have fuel, you gotta check your fuel line, your nozzle, you're gonna check your air intake, and you'll check your spark. So you have 3 things you have to always have at the right balance to have combustion or complete combustion. So, that being said, when you do troubleshooting, make sure you have your element correctly. Then you can see why are we're not getting flame. So it's good to think of that when you do troubleshooting. Few facts about transformers: they are tar insulated. So possibly if it overheats, it will melt. It should not be hot. It should not be placed outside. It should not be placed in a location where it's too hot or exposed to the sun or a lot of sources of heat. So that's why putting your washer and dryer close to the boiler is not a good idea. So tar, what is tar?
It's
Oil byproduct?
Oil byproduct or oil product. It's the lowest part of, after you take all the distillation from the oil, you get some tar, which is residual of oil, very heavy. So meaning, what is all oil product made of? 2 elements.
Old oil?
Oil products made out of 2 elements.
carbon,
Petroleum?
Yeah,
carbon and
Hydrogen?
hydrogen and carbon. That's why they call them hydrocarbons.
yeah, okay. I was trying to remember the
Hydrocarbons.
name.
Again, that's another question that you'll always find in the oil burning exam. All petroleum products are made of hydrogen and carbon. Different ratios, of course. What is air made of?
Oxygen, nitrogen, and other.
O2 plus hydrogen. No, I think nitrogen. Into it's around 79%. It's around 18% plus 3% other stuff.
What temperature does that tar melt?
Not very high. It's once you heat it to like maybe 100 to 120 degrees, it will start to become more viscous, and it might melt. So it's not very high. And also, we said before, hydrocarbon products are good food for what? What eats
Bacteria?
bacteria. So that's why it's completely insulated. If it's cracked and water got into it, bacteria will find good place to live, and it will start eating your tar. You start to see some byproducts. And if your tar is gone, what happens to the wires inside the transformer? If two wires become one, you have less electromagnetism, meaning you have less voltage coming out. So instead of 60,000 turns, you got 30,000. You have half the voltage coming out. Make sense? Moisture is a problem. High electrical consumption, up to like 100, 150 sometimes, which is a lot. They also degrade over time, depending on the situation, how much do you use them. So after you're using interrupted ignition, they last a little bit much longer than they used to. How to test a transformer? We're going to go over the steps again. Before you condemn a transformer, you want to make sure that it's not good, because again, a transformer is not cheap. It's around $150 to $200. And if you change a transformer and it's not the issue, you're still going to have delayed ignition. So this one is the tester, the test voltage. Can you test your transformer using your voltmeter? No, don't do that. What is the limit for your voltmeter?
1,000.
600 volt.
Really?
600 volts is the limit, the upper limit. You don't go above that. So you need a special tool to measure the transformer.
Even our little sticks, I think the max is 600 too.
Yeah.
Yeah.
It just give you like red light, but you don't see much. So you can test the resistance across the primary winding. Should be 3 ohms. What is the primary in this case? Here or here? Which one? This one, the 120. So you test the resistance across the primary. Should be around 3 ohms, plus or minus 10%. You can test the resistance across the secondary winding, which is here. And when you do that, make sure it's unplugged. You test the resistance when things are off. So don't do that unless you take it out. Test the resistance. Should be around 12,000 ohms, plus or minus 10%. That's a good way to test a transformer. And again, these are for specific models. It's like a general rule, but you can read on it. Some of them that will say what is the resistance supposed to be to help you test the igniters. Solid state igniters, they are very, very hard to test. You can buy a lot of tools to help you test them, but they're very hard to know if they're working or not. But the good thing is they either give you the voltage or they don't. Either it works or it doesn't. So if it works, it will give you 10,000 volts. If it doesn't, then it's not going to work. But they do go bad quickly, from what I've heard. So again, the lightweight, They are good replacement, they're quick, heat resistance, resistance to moisture because there is no coil inside, there's only a small board with electronics in it. And they are meant to be interrupted, not constant. Low power consumption, between 30 to 50 watts.
Is it like a big LED, kinda, if it's solid state?
No, it's different, different configuration inside. There's a rectifying system, and I think there's also a capacitor, and something to intensify the voltage. And again, they are not meant to be on all the time, but it gives you a lot of voltage. Again, back testing a transformer, another way to test it using an ohm meter. You can test the resistance between each prong. They should be between 10% of each other. And we did that in the lab last semester. Hopefully still have the lab sheet. When in doubt, you can also consult the manufacturer on how to test those transformers, but usually you can tell if it's giving you enough voltage or not. And one of the best ways to test it is to leave it running and test the amperage, because again, temperature does affect the voltage that comes out of it.
Mr. Bahan?
Yeah.
You can buy an adapter for high voltage.
What do you mean?
You can buy an adapter for your multimeter, it's like 90 bucks.
Yeah.
It's at 1 to 1,000.
How many volts?
1 to 1,000 volts, like whatever volt.
But
you
this is
read
10,000 volts.
So you would read 10 volts on your multimeter if you use the adapter.
Okay, I never
I just
knew
wanted
that.
to tell you that there is an adapter.
Does it go up to like 10,000 or 12,000?
I think it goes up higher than that because some of the
Yeah.
LED lights have high drivers now.
Probably they have better equipment. The one we have, tester we have is from the 60s, very heavyweight.
Right.
I'm sure they have new,
It's just in and
voltages.
out, it's the thing about that big.
yeah, you can check that out. Again, another way to test, this is the least, reliable way to test, it's just checking the color. It's very subjective to what you see, the time, the gap. They say bring the gaps together and look for the spark. Leave it for 5 to 10 minutes and it should not change color. And again, a new transformer will always give you a better spark. But I don't like this method because it's not very reliable. The better way is to put a meter in there and check the amperage drop. So I like this test. So basically, I'm gonna bring the gaps together, put them on an electrode and have them jump and measure for the amperage drop. Because this is a better way to know how much voltage are you producing. Because going back to Ohm's law, the amperage equals what? Voltage over resistance. So if the resistance here inside is sound, the amperage should not change that much. If the resistance is not as reliable or some of the wires are gone, after it heats up, probably it will drop the amperage. So going back to Ohm's law, if this is constant, and I have 10,000 volts here, this should remain as the resistance change, the voltage will change as well, and you can see the change by monitoring the amperage.
So you're measuring amperage in this test?
Yeah,
Okay.
and you measure the amperage and you wait for the change. It stays the way it is, or within 10%.
So that's actually working through the meter now. The
Yeah.
meter is completing the circuit so you can read the amperage.
Yeah, and this meter actually is not a clip-on, it's connected in series. But if you have a clip-on meter, just clip it on one of the wires or coil it twice, and just wait for the reading, and keep watching it for 5 to 10 minutes. Questions? And we did that last semester, hopefully you remember. And when we do troubleshooting, we'll test for those transformers. most of the transformer over here are in good shape, but we might put an old one and have you check it and see if it's okay or not. So cables, bus bars, and spring clips, those are all means to transport the voltage from the transformer to the electrodes. And again, electrodes have a distance to travel from the transformer, sometimes between 6 inches all the way to 1.5 foot or 20 inches. So high voltage, the secondary terminals in the ignitions, where you find your electrodes. So if the ceramics insulators are cracked, probably you're losing some voltage along the way, or sparking somewhere else. If you sparking partially to the plate, probably losing some voltage. If you go with industrial, industrial boilers where you have very long electrodes and a long distance between the transformer and the electrodes, you might want to trace the voltage and make sure it's getting all the way there. There were so many cases where you're actually getting voltage coming out of the transformer, but you go into the electrodes and you don't find the same voltage. It's very frustrating where you try to find where is it leaking, and there are ways to go and detect, but be careful again. You are trying to detect and trace voltage with 10,000 volts, so be careful when doing that. Electrodes, sorry, the metallic part now are sometimes a mix of alloy between silver and steel and platinum to give them a really good conductivity, and they are covered with porcelain, which is supposed to be a good insulator and can resist heat. So ceramics are one of the best things that can resist heat. They are better than metals when it comes to heat conductivity. I mean, heat resistance, not conductivity. And again, make sure you have the right length of ceramics. And how do you inspect those? Do you remember?
Just check for cracks.
Visually, check for cracks.
Oh, yeah.
Also lines, or what do they call it, fractures. If it's fractured, then you have to change them. There's another tool that I've seen, where you actually go and try to run a small light through it that will take the high voltage and to allow if there's any crack in it. But that's when visual inspection is not possible. And you can go through the entire porcelain and sure there's no cracks in it. Because sometimes you can see a hairline fracture that you cannot visually, it is that you cannot visually see it. It is a good way to measure that. And when in doubt, what I actually usually do, I will take the whole burner out and turn the ignition and look for the spark and see if it's there or not. And a lot of times those gaps wear out, or you get voltage all the way through the bus bars, but it does not make it all the way to the end. Or sometimes also the holders are conducting the voltage through the casing. Gaps are very important. So clean the electrodes. If those tips are designed to be pointy and they're all worn out, you have to change those. The gap makes a difference, and this tip makes a difference, and will give you clean conductivity, and the spark will jump clean between those two electrodes. Check connections, and also check insulation. It's one of the most frustrating issues. Why? Because you put it in, and still you have no ignition, or delayed ignition, which is really, really bad. Or you fix the equipment and it's, yeah, it runs, and you leave, and the homeowner calls you, hey, my furnace is not working. So before you leave, make sure it goes on and off many times, make sure it stays, and make sure you get the right voltage, the right spray angle, and also check your primary control for function. Sometimes it could have a malfunction, the program in it is changed, and it's going to safety for no reason, and it will take you a while to develop the sense of it. Sometimes these bus bars do not touch very well, but they touch but barely, or they can move, so make sure they're touching in a good way. What else could happen? These could crack, they could change. Again, sometimes you put it inside, you put back the electrodes and they are a little bit too far and they're touching the plate, so that could be another issue. And sometimes the spray angle has changed since the design, and you have too much oil covering the electrodes so it does not ignite. So That's why it's very important to put the ignition in the right location of the spray handle. So if you're, again, I think if this is your electrodes, I mean your nozzle and it's spraying, again, this area has more density of oil than this area. You agree? If these are your electrodes, it is designed to hit at the right spot where you have the right density of fuel and the right temperature. So if it's a little bit closer, it's going to be too dense, it's not going to light up. If it's too far, it's going to not light up as well. There's not enough density of fuel to light up. And that will concern the spark and the fuel. What else is remaining in the equation?
Air.
Air. If you have too much air, it might blow up the flame. If your air band is open all the way, too much air coming in will blow out the flame. And the temperature of air also matters. Is it room? Because if the room temperature is really that cold, you have to adjust the air band for it to be okay. Also, check for the air coming into the basement or wherever the boiler is. Make sure there's enough air coming in. If the air is not rich enough, doesn't have the 18%, it's not going to light up. So it's could be challenging. So these are some of the components: primary, iron core. We don't have to know what's inside. We just have to know how does it function. Output, electrode rods, and this is the gap. This is the whole ignition system, and it should work properly. Otherwise, you'll have no ignition. Again, some of the old transformers are confusing because both those wires are black. They're not both hot, right?
No.
Yeah,
You got that?
yeah.
I had somebody actually who wired both of them to hot. What happened?
Well, you have to check like their,
Burn.
Blew it up.
Doesn't matter which one is which?
no.
No. You guys got that? In a lot of transformers, these are colored the same, even though one is hot and one is neutral. It doesn't matter if you reverse them, but make sure one is hot and one is neutral. Because if you put too hot, that's how much voltage coming into. 120. It will burn. You'll see it smoke. Troubleshooting. If it's electrical problem, do you have power coming into the motor? Again, these charts are really useful and they are in your book. I don't know if you can see from that far, but it's in your book. Let me see which page is that. There you go. Chapter 9. Page 9-17, you'll see all those charts and give you possible ways to think of what could be wrong with this ignition system. Another chart. And the same will go for gas. However, with gas, we do not have ignition system. Sometimes we have ignition system, but it's not electrodes. Sometimes they have a glow stick. They call it a glow stick, which is a small piece of metal that gets really, really hot. It reaches the gas ignition point. And gas is easier to ignite than oil. Okay. There's a video on YouTube for primary controls, but I'm not going to go over it because we did that in the lab. Basically, it tells you what are the functions of primary controls or what are the different types. And at the end, you know, the primary control job is to monitor the functions of the burning. So what are we controlling? We have motor. The motor controls the fan and the pump, right? We have an oil valve. The oil valve permits the oil to go through the pump onto the nozzle. We have ignition, and ignition will go out. And we have our CAD cell that will verify the flame. All types of primary control do the same function. What is the safety timing on now? Just to prove light?
15 seconds.
15 seconds. Any more than that, and I think it's a waste because you're gonna pump oil into the chamber. It's unsafe. Okay, that's all.